All right, so we're going to be talking about who laid the groundwork for Charles Darwin's discovery of natural selection, and this will be by me, Hector Garcia.
Yep. Crash back in.
Eva Martinez and Grace Ferris.
So we're doing creative assignment 1, prompt 2, and we're going to be talking about people that contributed to Darwin's theory of evolution. So in this presentation, we're going to be talking about uniformitism, extinction, taxonomy, demography, and evolutionary biology.
Thomas Malthus was an English economist and demographer, and one of the leading examples that Darwin followed to create his theory of natural selection. In his lifespan between 1766 and 1834, he has created a multitude of books during his career exploring theories and the principles of population about the human race. His work mainly discussed his most well-known concept of how human populations tend to grow faster than the agricultural output, and how it applies over time and generations. Over time, the rise of populations increased the difficulty of maintaining the proper necessities. It doesn't just include food, but almost every aspect of living. Shelter, for example, is how people live and sleep. So when people demand it over time, eventually not everyone is going to inhabit a suitable space for survival. Malthus also believed that concepts like diseases, disasters, and predators existed to keep populations at a certain level, so one dominant species doesn't overthrow or massively grow to exceed the others. When Darwin was influenced by Malthus' readings, he also presumed that the same amount of logic also applies to other species, resulting in one of the keys to natural selection. A term he used to define it, how more offspring survive in their youth, causing overpopulations for a species, and having struggles, and for how long they struggled, is that certain aspects or characteristics start growing and adapt to their environment for a better chance of survival. This led him to write his own book, The Origin of Species, in 1859, and how evolutionary biology and the surroundings of nature of natural selection.
So the next guy we're going to be talking about is Carolus Linnaeus, and he was a huge figure on. He was a huge influence on Darwin. So he lived from 1707 to 1778. He was considered to be the father of taxonomy. His most significant contribution to science was creating a system to classify and name living things. The term would be binomial nomenclature system, and this was pretty much the two-part scientific name system that we use today. For example, how we have Homo sapiens for humans. Linnaeus, he believes that species were fixed and didn't change over time, but when he studied plants and animals, he gained a deeper understanding, and he started to notice variation within the species. And this suggested some species would have been more developed from hybrids. This idea opened the door to thinking about how things change over time. However, Linnaeus can pursue this as far as Darwin would. The important part is that he gave scientists a framework for organizing life by grouping organisms based on similarities. He unintentionally highlighted relationships between species, and Darwin, he used this classification system to demonstrate that these similarities were more effectively explained by common ancestry and evolution. So even though Linnaeus didn't come up with evolution himself, he was on the right track, and taxonomy was just a blueprint. Without the structure, Darwin wouldn't have had such a straightforward way to show how species are related and how they branch out over time.
All right, on to John Baptiste Lamarck, who was born in 1944. He was a pioneering French biologist who paved the way for Darwin's idea on the inheritance of acquired characteristics by introducing a mechanism that explained the impact and importance of an animal's physical environment and how it in turn shaped their physical characteristics. And so Lamarck's theory would eventually become known as the theory of acquired characteristics, or otherwise known as Lamarckism. And so it's important to note that despite this discovery, his theory, while it was relatively similar to what Darwin would later propose, his only mistake was believing that animals would acquire these traits during their own lifetime. However, that was later disproven by another biologist by the name of August Weismann, who conducted an experiment that involved amputating the tails of 68 mice and then successfully breeding 5 generations of them to observe whether future offspring would also adopt a swan tone, which they didn't. And as a result, Lamarck's ideas would soon begin to challenge the science established during that time period, which in turn led him to being discredited and harassed to the point of losing his money, his reputation, and his health. He would later die in 1829. But the important thing is that nonetheless, Lamarck stands out as the first writer to set both systematically and in detail a comprehensive theory of organic evolution that helped him to account for the successive prediction of all different forms of life on Earth, which helped pave the way for Charles Darwin's theory of natural selection.
Next, we have Charles Lyell, who began his career as a lawyer and later studied to become a geologist. He lived from 1797 to 1875, and throughout his studies, he was no longer interested in the teachings of geology from catastrophist William Buckland, and instead followed in the footsteps of geologist James Hutton, who believed that geology as a science could be observed over time to explain the Earth's past. Based on evidence gathered from James Hutton's work, Lyell was able to build on uniformitarianism, the theory that the geology of the Earth has remained unchanged throughout Earth's existence. Lyell provided enough evidence to support this by observing the flux of sea levels, where volcanoes sat, erosion in the Earth's surface, and how the surface shifted after big earthquakes, just to name a few. Lyell was a big believer in what happened in the past can still be seen today, as the processes behind geological events haven't changed. Throughout his travels, Lyell listed the changes that happened slowly over time and eventually published his book, The Principles of Geology, a book that would later help Charles Darwin in his theory of evolution. On Darwin's exploration of the Canary Islands, he was able to determine the island's history through uniformitarianism, which he had learned from reading Lyell's book. Darwin then applied the theory to the volcanic rocks he came across during his exploration. Lyell then spent the rest of his life revising his 3-volume book as new scientific evidence arose, continuing to support geologic science. While Lyell wasn't able to uncover the rest of Earth's geological history and finer details, he paved the way for scientists like Darwin to better understand the history of our Earth's surface.
George Cuvier was considered to be the father of paleontology. Cuvier lived from 1769 to 1832 and was a French naturalist and zoologist. Before his time, the idea of a species going extinct didn't seem possible until this man proved it. People believed that God wouldn't let a species die out, and if we found fossils and not the animal, we just hadn't looked hard enough to find that species on the planet. If Cuvier hadn't discovered extinction, then Darwin wouldn't have built off of that. I mean, if an animal can go extinct, could they change over time? Cuvier dug deep into his findings on fossils to back his claims. He believed different rock layers contain sets of fossils, finding that animal fossils like mammoths are not variations of elephants, but rather a whole new species. Because they hadn't seen this variation of an elephant, it couldn't be lurking around anywhere. Cuvier claimed it was just too big. Fossils found in old rocks seemed to be simple, while new rock fossils were complex, setting the groundwork for Darwin's theory that change and evolve was happening. The difference between the two was that Cuvier thought extinction happened because of big catastrophes, like dinosaurs, for example, while Darwin thought when evolution happens over time, a given species will change so much it will no longer exist, therefore extinct.